Hello everyone and welcome to another simple science video where we aim to explain simple scientific concepts. And in this video we are going to talk about graphs of kinematics. Graphs in kinematics are used to calculate the following 5 things. They're used to calculate distance traveled, displacement, speed, velocity, and acceleration. Surely things that we have talked about in the previous videos. Now let's get to the most simple graph, that is a distance time graph. And the total distance traveled at any time is indicated on the y-axis value of any time. For example, at time t equals 15 minutes, then the total distance traveled is 16 kilometers, 15 minutes, I'm sorry, not 15 seconds. Now the speed we can calculate as the rate of change of distance, as we have defined. But on a graph, it is the gradient of that graph. A gradient of that particular time. So for example, at time t equals 10 seconds, then the gradient is rise over run, and it is the same as the gradient of the line AB, which is, we can use 6,000 meters, which is 6 kilometers, divided by 15 minutes, which is 15 times 60 seconds, and you will get 6.67 meters per second. Now let's get to distance displacement graph. It's a little different. And similarly to the distance time graph, the distance from the starting position, or the displacement, is basically the y-axis value of that time. Similarly, like at time 5 seconds, the distance from the starting position is 5 meters. Now, velocity can also be calculated on the distance time graph because velocity is the rate of change of displacement, and therefore it is the gradient at any particular time on that graph. For example, at the time t equals 11 seconds, the velocity is numerically equal to the slope of that final part of that graph, which we can calculate as 5 meters divided by 2.5 seconds, which is the rise over run, but we have to make that answer a negative because the gradient is negative. So in this case, the velocity is going against the motion. Now let's look at the velocity time graph. Now velocity at any time is basically the y-axis value for that time. For example, at time 3 seconds, the velocity is 2 centimeters per second, as indicated on the graph. Now, on a velocity time graph, we can also calculate the total displacement after any particular time, and that is the area under the graph up to that time. For example, up to the time t equals 4 seconds, the total displacement is the area of the trapezium that bounds the graph with the x-axis. That's the area under the graph up to that time. We can calculate it as half times base at height, and then half times a plus b, and then multiplying by the height. In this case, it is half times 1 plus 4 multiplying by the height of the trapezium is 2, and you should get 5 centimeters. Also, in a velocity time graph, we can also calculate acceleration at any particular time. As we've defined in the previous video, acceleration is the rate of change of velocity. So therefore, acceleration is the gradient of that graph at any particular time. So at the time t equals 4 seconds, the gradient is rise over run. It is the gradient of that third part of that graph, the part that goes from 3 seconds to 5 seconds, and we can calculate it as minus 4 meters per second. That's the change of velocity divided by the total time, gives you minus 2 meters per second squared. Now, acceleration time graphs are probably new to most of you, and we can calculate the change of velocity. And it is essentially the area under the graph up to that particular time. For example, up to 2.5 seconds, then the change of velocity up to 2.5 seconds is the area of the graph up to that point. And it is 2.5 times 0.4 should get you 0.6 meters per second. Thank you for watching. If you like this video, then support me by subscribing, liking, and commenting good things on my video. I'm kidding.